I'm Anil Kumar. Welcome to my series on trigonometry. We are almost at the end. Now, let us prepare for the test. The formulas which you need to remember are shown here. You can actually pause the video, copy these formulas. Try to remember them. They may not be provided in the test paper. Now, these formulas which I have mentioned are based on compound angle formulas, where we're talking about sine, cosine and tan with a plus b or a minus b angles. Then we have double angle formulas, how we can use cos 2x in three different ways. Half angle formulas, product to sum or difference, and then we have sum or difference to product form. These are kind of essential to know to take up this test. Now I've selected few questions from previous test papers, and I hope if you do them, you will get good marks. So the very first question here is to express as a single sine or cosine function. Cos 3x, cos 5x minus cos 3x, cos 5x, sine. So it is cos 3x, cos 5x minus sine 3x, sine 5x, and b is 3 minus 6 cos square 7 over 2x. You can pause the video, answer the question, and then look into my suggestions. Take it like a real test. It will help you. Now here is direct application of cos of a plus b formula, correct? So you know cos of a plus b is what? Is cos a cos b minus sine a sine b, right? So the right side is given to you. So you can actually combine and you can write this as equal to cos of 3x plus 5x, and therefore it could be written as cos of 8x. Perfect. So that is simple. The second one here is also of one of our formulas in the list. This is a double angle formula. So if you recall, the formula which is given here is of cos of 2x. Cos of 2x is 2 cos square x minus 1. Now let's look into the question. We are given 3 minus 6 cos square 7 over 2x, correct? So if I factor minus 3, if I factor minus 3, what I get? This becomes positive 2 cos square 7 over 2x, correct? And since I factored minus 3, I'll have to write this as minus 1. Now inside function is 2 cos square x minus 1 times. So it could be written as cos of 2x, and therefore we could write this as minus 3 cos of 2 times 7 over 2x, which is clearly equals to minus 3 cos of 7x. Do you see that? So that is how we could directly apply the formula and do the very first question. Let's move on and take the next one. The question here is, determine two equivalent trigonometric functions for sine 8 pi by 13. One using related acute angle identity and the other using correlated acute angle identity. So read the question properly and then answer. So what we are given here is sine of 8 pi by 13. So 8 pi by 13 means this will be pi, right? So pi could be written as 13 pi by 13, right? So 8 pi by 13 will be somewhere here. Half is 7.5, right? 6.5. So somewhere here. So we have 8 pi by 13 in quadrant 2. So in quadrant 2, we are looking for sine of 8 pi by 13. So it is positive, right? Since we know that all are positive here. Sine is positive here, tan positive in 3, and quadrant 4 cosine is positive. So we are expecting a positive value. So that is one thing. Second is We want related acute angle. Now in this case, the acute angle is how much? If we know this is 8 pi by 13, then the remaining is 5 pi by 13. So it could be written as sine of 5 pi by 13, right? So this is 5 pi by 13. That is going to make us 13 pi by 13. So that is our answer for the first one. And the second one is correlated acute angle, right? So when it is correlated, we are looking for 90 minus, that is pi by 2 minus this particular angle, right? So if I sketch this here, kind of, let me just do it here. So in that case, if this is 5 pi by 13, then we could write this as cosine function, right? Cos of pi by 2 minus 5 pi by 13. Correct? So that becomes correlated acute angle. Correct? So you need to do a bit of calculation. 26 becomes the common thing, and so it becomes cos of 26, and that gives you 13 pi minus 10 pi, and that is equals to cos of 3 pi by 26. Do you understand? So that is the second answer for the same question. So for correlated, you have to write in terms of cos, and the identity used is cos pi by 2 minus theta equals to sine theta. Perfect. And sine 5 pi by 3 is used here. So that is how you're going to do it. So I hope it is absolutely clear. Let's move on and take up a trigonometric identity. Now this is a very interesting identity. If tan theta plus secant theta equals to x, prove that tan theta equals to x square minus 1 over 2x and sine theta equals to x square minus 1 over x square plus 1. Okay, so let's take a break here. Let's go for a walk, come back, and then continue with our solutions. I hope that'll be interesting, right? I hope you enjoyed the break. As you saw, there are many paths leading to the solution. Now I've done this question in a different way earlier. This time we'll follow a much simpler method. If tan theta plus secant theta equals to x, we need to prove tan theta is x square minus 1 over 2x and sine theta equals to x square minus 1 over x square plus 1. Well, you remember one identity, which is 1 plus tan square theta equals to secant square theta, right? So from here we could write secant square theta minus tan square theta is equal to 1. And this is kind of difference of square. So I could write this as secant theta plus tan theta times secant theta minus tan theta is also equal to 1. What are we given? We are given what is secant theta plus tan theta is. So we could write this as x times secant theta minus tan theta equals to 1, or we get secant theta minus tan theta equals to 1 over x. Correct? So what you notice here is that we are given that secant theta plus tan theta equals to x. So this is given and we just found this. So let me write this as equation 1 and 2. Okay. Now from this equation we can easily find what tan theta is, right? So if I do equation 1, lower one, minus equation 2, then secant cancel and I get 2 tan theta equals to x minus 1 over x. Do you see that? So from here we get the expression for tan. Well, so we get 2 tan theta equals to x square minus 1 over x. Let's take it on this side and write down the result, which is tan theta is equal to x square minus 1 over 2x. Now that is what we wanted to show, correct? Now let me do another thing, which is what I will do now is I will add these two equations. Now if I add equation 1 and equation 2, in that case, what do I get? I get 2 secant theta equals to x plus 1 over x, which is x square plus 1 in the numerator. So that means that secant theta is x square plus 1 over 2x. Do you see that part? Well, we wanted to find sine theta, but I found secant theta. Anyway, it also helps. The idea is sometimes you may be given cos theta, secant theta. You know, we can find anything, right? We can find what is cos theta, we can find what is secant theta. So it could be anything in your test paper. So let's be open. This was very simple to find. So now what I'm considering here is a right triangle. And in this triangle, we have angle theta right there. Tan theta is x square minus 1, opposite over 2x, that is tan. And if you see, secant is what? Hypotenuse over this side. So hypotenuse is x square plus 1. So our triangle is complete, right? So from the triangle, we can write what sine theta is equal to, right? So sine theta is x square minus 1 over x square plus 1. Does it make sense to you? Right? You could also write what cos theta is. Cos theta will be 2x over that. So this question is very popular and it could be asked in many different ways, and therefore it is good to look at it from different angles. I hope you understand and appreciate it. Let's move on and take the next question. This time we are given cos x equals to minus 5 over 3, where x is between pi by 2 and pi, and we are given tan y as 4 over 3, where y is between pi and 3 pi by 2. So let's make our coordinates. So what we are saying here is that cos x is within pi by 2 to pi, that means in this quadrant, quadrant 2, and tan y is in quadrant 3. Perfect. Now that is important to understand to find all the values. In quadrant 2, we know sine is positive, and in quadrant 3, tan is positive. Perfect. So knowing this, we can get all the values and then we'll find the solution. So let's make our triangles first. So, okay, so let me sketch the first triangle, which is in quadrant 2. Okay, so I've drawn it the other way. It really doesn't matter. We need to only consider that in quadrant 2, sine is positive, rest are negative. When we say cos is 5 over 3, that means 5 and, this is something wrong. Cos cannot be 5 over 3. So, typing error. So, cos has to be 3 over 5, right? So, I'm just changing this. 3 over 5. Okay. So, I just changed this cos to 3 over 5. So, definitely, it cannot be 5 over 3 since the value has to be less than 1, right? So, we get 5 as the hypotenuse, 3 as the base, and the other side has to be 4. So we could write from here that we know cos x is equal to minus, you are in quadrant 2, 3 over 5. Sin x is equal to positive 4 over 5. Correct? Now let's look into the tan thing. Okay. Let's also see y, the second quadrant. We are in quadrant 3 now. For tan y, 4 over 3 is the value. So quadrant 3. And the other triangle is with the values of 4 over 3 for tan y. So this is y. Then it is 4 over 3. And this is 5. Since you are in quadrant 3, sine and cosine are negative. So in this case, cos y will be negative 3 over 5. And sine y is going to be negative 4 over 5. Correct? So we know all the values. And now it is simpler to find sine 2x and tan of x plus y. Correct? Okay. So let's figure it out. So the first one here is, let's say sine 2x. Sine 2x equals to 2 sine x cos x. So that gives you the value of 2 times sine x is 4 over 5 and cos x is negative 3 over 5. Correct? So we get a negative value. Denominator is 25 and the numerator is 8 times 324. Correct? So we get one value. For tan x plus y, what do we get? The formula, tan x plus tan y over 1 minus tan x tan y. Now what is tan x? Let's write down tan x also. So tan x will be 4 over 3 with a negative sign since you are in quadrant 2. So let me write in a different ink here. Tan x is 4 over 3. We are given tan y also 4 over 3. Right? But this value is negative since we are in quadrant 2. Okay. Now let's write down the values. So we get here tan x as minus 4 over 3 times, plus tan y, which is given to us as 4 over 3, divided by 1 minus product of these two, which is minus 4 over 3 times 4 over 3, right? Since the numerator is 0, the whole thing has to be 0. So this is equal to 0. And for tan sine 2x, we get minus 24 over 25. Is it correct? So that is how you're going to get the solution. So I hope that's perfectly fine. Let's move on and take the next question now. We need to prove the identity tan pi by 4 plus x plus tan pi by 4 minus x equals to 2 secant 2x. So let's begin from the left side. And we'll apply the formula tan a plus b. So which is tan pi by 4 plus tan x over 1 minus tan pi by 4 times tan x. Plus, in this case, it will be tan pi by 4 minus tan x over 1 plus tan pi by 4 times tan x. As you know, tan pi by 4 is 1. So we can replace this by 1, and what we get here is 1 plus tan x over 1 minus tan x plus we get 1 minus tan x over 1 plus tan x, correct? Now we can take a common denominator. Multiplying these two, we get 1 minus tan square x. Cross multiply, so we get 1 plus tan x whole square plus 1 minus tan x whole square. Perfect. Now what we need to do is just expand the numerator. Okay, let's go this side. So if I expand, I get 1 plus 2 tan x plus tan square x for the first term, and then here 1 minus 2 tan x plus tan square x over 1 minus tan square x. Now in the numerator we get 1 plus 1 as 2, and then 2 tan x minus 2 tan x cancel, and we get plus 2 tan square x over 1 minus tan square x. Now 1 minus tan square x could be written as 1 plus tan x, and 1, or we could write it in sine and cos, right? So we could do either way since we need secant here. Okay, because, okay, let's continue. We'll keep this as 1 minus tan square x itself. Okay. And now what we will do here is we'll expand the numerator, rather factor. We get 1 plus tan square x, which is secant square x, right? And we get here 1 minus tan square x. Now the numerator is 2 times 1 plus tan square x is secant square x, and in the denominator we will write this as sine and cosine. Okay, we want secant 2x. Okay, so we will write this as 1 minus sine square x over cos square x. Okay, so that gives you in the denominator cos square x minus sine square x over cos square x, and here we have 2 times 1 over cos square x. Do you see that part? So this cos square x cancel, right? So what you get is 2 over cos square x minus sine square x, which in the denominator will be cos 2x, or could be written as 2 secant 2x, which is the right side. So that is how you're going to prove this identity. So I hope the steps are absolutely clear. Go through this proof once again, as it's very critical from test point of view. You might just have this question in your test. Okay, so let me take one more question to close it, and then in part B we can take some more. Okay, so now we'll head in for the last question. I hope you found the selection of questions good enough for your practice test. Here is the last question. You can always pause the video, answer, and then look into my suggestions. Now we'll begin from the left side again. So on the left side we have 1 plus tan x over 2. So I'll write down this as sine x over 2 over cosine x over 2. Similarly in the denominator, I'm going to write this as 1 minus sine x over 2 over cos x over 2. And now we can multiply by cos x by 2, right? So we get here cos x by 2 plus sine x by 2 divided by cos x by 2 minus sine x by 2. So we multiplied by cos x by 2 in both numerator and denominator. Perfect. Now what we could do is we could rationalize this. So we are going to now multiply and divide by the conjugate of denominator, right? So we will do now cos x by 2 plus sine x by 2 divided by cos x by 2 plus sine x by 2. So we just multiplied this by 1 basically. So when you do that, you get difference of square in the denominator and a perfect square in the numerator. So we'll expand the numerator, which is cos square x by 2 plus 2 cos x by 2 sin x by 2 plus sine square x by 2. And in the denominator, what you get is difference of square, which is cos square x by 2 minus sine square x by 2. Perfect. Now, cos square x by 2 plus sine square x by 2 is 1, correct? These two, they add up to 1. So we get 1 plus, and here we have 2 sine x cos x, so which is sine 2x. So we could write this as 1 plus sine x. Do you get the idea, right? So we applied the formula here, which is sine 2x equals to 2 sine x cos x, right? And we have also applied cos square x plus sine square x equals to 1. So we get numerator of 1 plus sine x, and in the denominator it is cos 2x, right? So which is cos of x. So the third formula which we have applied just now is, let me write cos 2 theta equals to 2 cos square theta minus sine square theta. So these three formulas helped us to get the result right there. Correct? So twice x by 2 is x, right? Now this could be written as 1 over cos x plus sine x over cos x, and that gives you the required result, which is secant x plus tan x. Perfect. So that is how you could actually prove the last identity. So I hope you find it interesting and useful. Feel free to share my videos. In the next part, we'll take up examples relating to double angle and finding angles with half and double angles. So we'll concentrate more on equations and other parts rather than identities in the second part. But I hope this makes sense. Feel free to write your comments and share your views. Thanks for watching, and all the best.